Morning, everybody. So what I'm going to do this morning is I'll give you a quick overview of what Project Clearwater is and how it works, and then what the scaling demo consists of, and then we'll plug Andy's laptop back in, which I just unplugged. Hopefully it will work, and we'll plug it back in, and we'll kick the demo off and show it working to you. So, Project Clearwater, what is it? So the architecture of it. Basically, it's an open source IMS core platform. There are two modes of it working. There is a open source Project Clearwater. There is a Clearwater core, which is a supported platform by Metaswitch as a company. James mentioned Manx Telecom. That's what Manx Telecom are using, the supported platform. We're using today in this demo the open source Project Clearwater version. And it consists of a number of different nodes. It doesn't look like an IMS as such if you look at GSMA architecture, but it does provide all the function that IMS adds or contains. So the components we're using, and these will appear in the Juju, they're in the charms, they'll appear in the Juju GUI we'll see in a moment. The key one that we're looking at is this component Sprout. It stands for SIP router, and that provides the core I and SCSCF function in an IMS core. And that's what we're going to scale up and show load going into the system. We have on a front end Bono, which acts as a PCSCF. Essentially, in this case, we're using it as the edge node into the network. And we have a UE. We're going to use a test tool called SIP-P to drive traffic through the network. We have another component, Ralph, which is instantiated. It provides CTF, charging trigger function, generates RF billing records out to a CDF. There is no CDF actually in this demo, but we have got one we could deploy. And then we have components Homestead and Homer. They basically provide the configuration information. And in a typical IMS deployment, it is connected into an HSS. In this deployment, we're running it in a standalone mode where it's its own self-contained data store. There is no separate HSS for this purpose of this demo. So very quickly, what's Sprout do? Sprout basically provides the I and the SCSCF functions for all of you familiar, anybody familiar with IMS technology. It's written in C, C++, and it's built on top of Memcached as a distributed data store. It acts as a stateless node that you can just scale out, and you can add more nodes into it to add more capacity. And that's what we're going to show in a few minutes during this period. And if a Sprout fails, then all current registrations and calls stay in place. They're transaction stateful, but not dialog stateful. So it means if somebody's in the process of setting up a call, they will restart the call, send out a new SIP invite, and the call will go through. If a call's actually up, it will carry on in the network. It will just stay there. Bono, I mentioned before, that provides the edge processing. It's basically, in this case, we're using it for NAT traversal to get into the network and provide edge processing. Homestead, this is acting as a subscriber store, so we've got all the subscribers configured into this. It is based on top of Cassandra, which is an open source distributed database, and the database provides the subscriber information and the authentication. So when the subscribers from the test tool register, they get the authentication credentials out of the Cassandra database. So this acts, and if you're using an HSS, it acts as a front end to the HSS into the network. Ralph is the charging trigger function. It generates RF events. It's notified about all the calls, and it stores call state in Memcached and Chronos, which is a distributed timer store. So what's the demo actually involve? So we've got Project Clearwater. That's those components in the middle, and we'll show this in the middle in a minute on the Juju. They've been charmed up by Juju, so they are instantiated. They're running in Amazon EC2. Each of them is running in a separate individual machine on Amazon EC2. We've got SIP-P, which is acting as a load generator. We have Zabbix, which is monitoring CPU load on the system, and then that is communicating with Juju to spin up new nodes when required. So it's deployed on Amazon EC2. We're using Canonical as the Juju as the orchestrator. That has spun it all up. we have got the system spun up now. We're going to kick off the load in a minute, and then it will automatically scale. Project Clearwater is running as the IMS core. SIP-P, when we start it, will add SIP traffic. It's going to ramp up to 40,000 BHCA over the course of about the next 10 to 20 minutes, and it's using 30-second average call times. And then Zabbix is monitoring the CPU load on the Sprout nodes. And there's a trigger sent in Zabbix to see what the load. The load measure is actually the average number of queued processes. This is just what Zabbix uses to monitor. There's a trigger set at 5, and we'll see that in a moment. And when the trigger is hit, Zabbix instructs Juju to create a new Sprout node. The Sprout node is instantiated. It's added to DNS. It's using DNS load balancing, and the load will get shared across the multiple instances. And this will take about 20 to 30 minutes in total, and we'll kick it off now, show it starting, and we're going to come back 2 or 3 times during the course of this morning to show where we've got to and what's actually happening and the new nodes being created and put into the network. So with this, Andy, I'm going to switch back to your screen.
Brilliant, yeah, and whilst we're switching over, I'll just recap that again. So what we've done is we've got our IMS core here, which incidentally is then bolted into the Trifone mobile network. We've got 100,000 plus UK mobile numbers bolted onto it, just to make it real so that we can interact with it. And we're going to spin that up in a second. Andy Smith here in the front row is going to kind of build that so you get a feel for how quick and easy it is just to throw this out on the ground or in the cloud, as it is. And then we're going to start loading it up with traffic. The loading, by the way, is being run from London using SIP-P. And so the whole point of that is to watch how it grows. Right, I think we're ready to go, aren't we?
We're ready to go. Okay.
Do you need a microphone, Andy?
I wasn't sure I was talking on this.
Well, you can now.
Okay, right. So what I'm about to do, let me just go back to what I had there a second ago. So this is an empty Juju thing. If I can possibly get rid of that, it doesn't really matter. There is just the GUI node there at the moment. So what I am now going to do is to kick off a build which will populate it with what you just heard. So the what happened there? That's the one, right? Which will now start to populate it with Project Clearwater. No, it won't. Yes, it will.
Yeah, it's starting, is it?
It's starting to deploy services. So we should see in the top here as it starts to deploy services. So that will then be reflected onto the GUI. So as we look at that, we can go back to the GUI, and that will slowly, if I can get it to show them. There you go. Show the various nodes starting to appear. Okay.
What's going on here? Yeah. Here you have Nicholas Thomas, Canonical, pretty obvious. You can refresh the page. Okay. Juju, as Arthur explained this morning, is a universal modeling tool to any workloads. And we build it looking at how people do software. They usually go to a room with architects, take a whiteboard, and draw boxes, and you will see lines in a minute. When we see that, it came from studying people early on the cloud, using the cloud like a photocopy. And we are like, this is an API. We can do better than that with an API. So we did. Instead of having guys in a room, drawing boxes and lines, waiting 9 months, studying data to have the right to do 1 week of test, here the tool is doing it. You have your boxes, you reuse from the store. You don't have to invent or to install MongoDB, to install a big data solution or anything. We already have that in the store. You just reuse it, you connect to it, and you focus on what matters to you. Remember the Swedish cook. That's the way to stand on the shoulder of giants. And Paul mentioned the details of what this demo runs on. Juju abstract the cloud for you. So it doesn't matter if it's on Amazon or Azure or Giant, on-premise, on your laptop. You define your service. And think about it. Your architecture, the way you describe your architecture and your different service, does not matter where you run it. It's a deployment time problem. So this is what the GUI is for. And that's why the GUI is important out of just being nice for demos. It's the thinking of services and relating services. And then Juju helps you and does the dirty job of finding a machine, installing the software on it, configuring it, etc. We don't do that manually anymore. Nobody's doing that in Canonical, and less in our partners wants to do that anymore when they face this. And because that clean differentiation between your model and your instantiation, your testing, you can have the same model scripted, because you can export, send that model to you, and you can install it on your cloud or on your machine, which means the architects define a model that goes through the whole chain, from the architects to testing, implementing, testing, going back and forth to production. And that's the really powerful message around it.
Yeah, and we do it in a fraction of the time that you would deploy conventional infrastructure.
Just look at the demos, at the dangerous demos. A year ago, we barely have one, and here you're going to have 10, 15 demos. A little bit less. I'm in sales. 8 demos running with the different partners that joined last year. In a year, we have so many new things we could do with partners joining in, and because we model things, the other guys using your model directly understand it. It's obvious to them what to do with it, and they can try it, and they can do it. Actually, you can do it. That demo is on GitHub. You can do it yourself. It's a do-it-yourself demo that you can run on any cloud you have access to.
Indeed. In fact, it's github.com/tad-demo2015/vaz-jams-dev. If anybody wants that, we'll promulgate the URLs later. So, whilst we're waiting for that to build.
So, just to explain what's going on here, this is building an environment. You can't see it here, but these are all the individual Clearwater nodes. The green ones are up, and the orange ones are being built. Because this takes a while, and if you switch to the other one that's up, so the other Juju, that one, right. So here's one that we put together ahead of this for the demo. So you can see this has got, it's a bit hard to see here, but these are the Clearwater nodes, and this is the Sprout node. This is Zabbix, which is doing monitoring of them. We've got, this is, that's RESTCOM in here. And what we're going to do now is we will kick off the scale test. So Andy, if you want to go to that environment and start that, and this is going to start SIP-P. So while Andy's doing this, Andy's going to kick off the scale test, and then we will show you Zabbix is monitoring the components in there. So we'll show you Zabbix, and that's working. So
the wonderful thing about this is all being carried out live with no safety nets.
Yeah. Okay. So TADS1's the environment we've just shown you with the components already up, and Andy's just going to kick off that's the relationship. That's basically kicking off the relationship between SIP-P and Bono, which is kicking SIP-P into doing the traffic. So you kick that off, Andy. Okay. And then if you swap to go back to the Zabbix screen. So we bring up Zabbix. So this is here, this is monitoring. So this is the first instantiation of Sprout 0. There's only one instantiation here at the moment. And this is just monitoring the CPU load. And I said that there's a trigger of 5. You can see that there are housekeeping tasks, but fundamentally it's sat at the bottom with no load with something just over 0. And that is ongoing. What we will start to see now, and we'll come back and show you this later on, is this load will ramp up. And it will ramp up. Once it hits 5, then it will hit the trigger. And Andy, if you can jump to the triggers bar here, you can see that there's a trigger here which is set up. And at the moment, it is saying that the average CPU load is very low. So it's not hit the trigger. That we will see later on will actually ramp up. So that's kicked off now. It's going to take 10 minutes, 20 minutes, 30 minutes to actually run. It will ramp up, depending on how long we lead it, or it will ramp up to probably 3 Sprout nodes with the overall traffic load.
Yeah, and what sort of total volume of calls are we looking at?
We're going to send through 40,000 BHCA and their 30-second call length. So it's about 20,000 concurrent calls running through the system and 40,000 busy hour call attempts.
Yeah, and note, these are real calls with real media.
And just if I can add a little thing about the Zabbix stuff.
Well, we're slightly over time,
just a
but
word.
go for it.
It's irrelevant to Juju which monitoring system it is, and that instance of the monitoring system is external to what Juju controls. What we have in Juju, if you can switch to GUI, we have the capability to put agents. So this box here is actually going to put agents on all the units of all the service it's related to and tell Zabbix about it. So put the agent and tell the external monitoring system or fault management, whatever system outside that you already have, you already spend billions on and you don't want to replace because we propose you something, you can keep them and integrate with it. And in Zabbix, we give the API to the Juju environments. So the only thing your operation have to do is to monitor a metrics and tell to the Juju API, if that goes up, add a unit of Sprout, add a unit of this other stuff, and Juju takes care of the rest. And that's the real benefit of this.
Yeah, the scalability piece. Brilliant.